town, like Somalia. So they extrapolate the relationships they found when they have data to the rest of the world to come up with estimated precipitation. And that's where the GPCP data comes from. Let me pause for a second. Any questions or thoughts on that? Yeah.
So do the GPCP generate data that you use, or do you have to go and create algorithms to figure out?
The meteorologists do it for you. They've already estimated the relationships, and they have the predicted data out there. So that saves you one step. Any other questions or thoughts on this data? Yeah, Lauren? Yeah. So since we started working on this project, which was like 10 years ago, there are more finely grained series, better series. So the University of Delaware data is closely related and using a combination of sources, but it has longer time period, et cetera. So more people these days are using the University of Delaware data than the GPCP data. So first of all, over time, the satellite data is getting higher and higher resolution, but of course that only goes back to a certain point. But the sort of techniques we use to combine weather, ground station data, and satellite data are also becoming better. So this is what some of the data looks like. This is just a snapshot of global precipitation for a subset of the month of January 1999, where the darker kind of purple and blue colors denote more precipitation, the lighter colors denote less, and actually, you can't even see the individual pixels here. They're, because there's correlation across neighboring pixels, it sometimes looks like, if you go to some parts of Central Africa, like there's a big green blob, but that's made up of multiple different smaller pixels. But basically what we do is you get snapshots like this every month over many years for hundreds of pixels in sub-Saharan Africa, and you come up with the measures that we use. And what this allows us to do is estimate the relationship between rainfall and growth. And what we do actually, we look at what I'm calling growth, changes in rainfall over time, and how those link to economic growth or changes in income over time. Turns out there's a lot of predictive power there. You could also use rainfall levels here, and you get a similar answer. You could use the level of rainfall. Or actually, what people really do is they use the deviation of rainfall from the long-run historical mean. That's the most commonly used measure today over the last few years, although some people still use this growth specification that we used. Okay, so we're regressing growth on rainfall, and there might be these other factors X that also affect growth, the same ones we talked about before. Let me pause for a second. You're going to notice some subscripts actually here. Let me just mention. You see the subscript 1. You're going to see a subscript 1 coming up, a subscript 2, and a subscript 0. And those represent the 3 different regressions you need to run in an instrumental variables approach. The one here, this is called the first stage. And I'll explain this all in the next 15 or 20 minutes. There's the first stage. There's the second stage. That's the 2. And then there's what's called the reduced form. That's the one that has the 0. I'll talk about that. Okay, so just keep in mind there's going to be 3 regressions we're going to have to focus on. Yeah. I'll get there. Yeah, I'm just giving you the link a little bit, but we're going to talk about that. And I'll tell you very precisely what the reduced form is. Any other questions? Yeah. Yeah. Well, here we're not doing that. We're using the change in rainfall. We're doing rainfall growth. But when people use the deviation from the historical mean, of course they want to use as long a historical record as they can. So they'll try to go back as many decades as they can when they do that. Here we're just looking at year-to-year changes in rainfall. So it kind of simplifies things for us. Yeah.
So the reason why you did that way, or you did it in 2013?
I think we would do deviations. We did try with deviations at the time. The real reason we did it this way is we had more predictive power here in the first stage, and that's important in instrumental variables methods. That was really the reason we did it this way. It turns out that the changes year-to-year in rainfall predict income changes very strongly. The deviations from the mean also predicted pretty strongly, but this worked a little bit better, so we went with this. Now, the rest of the literature over the last decade has very much converged on the deviation from the mean as a kind of standard measure. But at the time we were doing this in social sciences, people weren't really using this data that much, so we were sort of trying different things and trying to figure out what worked. Yeah. Say again. Speak up a little bit.
Why did you add logs between these variables? Because we have those sources.
Why not use logs? You certainly could, if you wanted to. You could say, in some sense, a growth specification is like a log specification. If you look at, logs as capturing proportional changes, at least in a first-order approximation. So it's not that different than looking at things in logs, but it wouldn't change things very much here with these functional forms. Okay. So what do we find? This is a table from the paper. The outcome measure is economic growth in year t, really between t minus 1 and t. And I'll just highlight the first column there. The first row is growth in rainfall in year t, and the previous one is growth in year t minus 1. And you can see both of those very strongly predict economic growth. What is one reason why growth in t minus 1, growth in rainfall in t minus 1 might matter? Yeah. So part of it could be it takes time for for rainfall shocks to translate into income. If you have a harvest cycle, it may last many months. So lagged rainfall might affect outcomes today because rainfall 6 months ago might be affecting my crop yields today. Yeah. Exactly. So the bad year last year not only affected me last year, it may affect me next year because I couldn't save enough to buy better seeds next year, et cetera. So maybe it's not too surprising that both current and last year's rainfall growth enter in significantly. And you can see the t statistics are pretty large. They're 3 or 4 there. So there's a lot of predictive power. In other words, when rainfall is increasing in sub-Saharan Africa, growth tends to be increasing. And that's in part. Remember we plotted out the distribution of rainfall in sub-Saharan Africa versus other regions of the world from Bloom, sort of in our discussion of Bloom's Tax. Sub-Saharan Africa is drier than other regions of the world on average. There's just a lot of arid and semi-arid regions, and in those regions, having a bit higher rainfall is really good. Crop yields are higher, economic growth is faster. Okay, so the idea behind instrumental variable is to take advantage of the fact that we have this ID, this instrumental variable, rainfall growth, that affects economic growth to understand the link to conflict. And this is how it works. 3 conditions have to hold to have a valid instrumental variable. Now there's different ways of presenting this. I'm going to start with the sort of logical argument. So think of this almost as a philosophical or logical argument. What conditions would you need to hold in order to reach a certain conclusion? And then I'm going to show you the equations, but I think it makes sense to think about the logical argument first. So the first thing we need is what's often called the relevance condition, which is to have a valid instrumental variable. We need a variable, in this case rainfall, that has some predictive power for economic growth. It has to drive economic growth. This is the first stage. You need an instrumental variable that does this. If you don't have, if the variable you have that you're calling your instrument doesn't affect economic growth or whatever that next variable is, we don't have an instrument. It's not a driver of variation in growth. Yeah. There is, and it's very important to have very high levels of statistical significance in that relationship. If you don't, you run into what's called the weak instruments problem. So what ends up happening is you can't necessarily say the first stage is like good or bad. It's continuous. The correlation between these two variables will kind of, between different variables could be a little bit better, a little bit better, a little bit better, until maybe it's very strong. And the question is, at what point do we just shut down the exercise and say my instruments are so weak that they're not useful? So there's an extremely active branch of applied econometrics over the last 20 years that's trying to understand the properties of weak instruments. So that's an incredibly important thing. In fact, the instruments that we have are on the borderline of being acceptable. They're okay, but if those first stages were a little less significant, we'd be in trouble, basically. Even though they look pretty significant, right? So you actually need a lot of statistical significance in the first stage, yeah.
Theoretically, that doesn't have to be directly causal. Does the average cause X correlate with equal?
That's what we're going to get to next. That's really going to be the key kind of next condition we're going to get to. So they have to be correlated. That's step one. There are going to be two more conditions needed. This alone isn't enough. So the more of the variation you explain, the more precise your estimates are going to be later on. So they both matter. Statistical significance matters, but so does how much of the variation you can explain. Yeah, they're both going to matter. They're both going to matter. And there's something else that's that's important, and I don't want to get into it too much because let me talk about the basics first. But you guys are kind of hinting at it, sort of implicit here, which is a certain variable may be a good instrument for a certain population, for a certain subset of your data, but not others. So for instance, if you run our first stage, I just showed you, in the US, you won't have a very good first stage. Rainfall patterns do predict economic growth in the US, but very weakly. Because the US isn't a very agricultural society. Agriculture is a very small share of the economy. So, but it does a little bit better in Latin America, and it does a little bit better in South Asia, and it does really pretty well in Sub-Saharan Africa. So in different populations, you have an instrument that's weaker or stronger, more or less relevant, and therefore you can sometimes only use a certain approach in a certain subset of your data. So we started this project, we thought, here, we have this great idea, let's use rainfall variation, let's look at the worldwide sample. That's how we started, but we didn't have a first stage in most of the world. We had a first stage in Sub-Saharan Africa, we focused on Sub-Saharan Africa, that's how it worked. Okay, that's the first stage. You need a variable that's driving economic growth in this case. Now we're going to start getting some of the points that are raised there. The second condition is called exogeneity. So we already talked about endogeneity. Endogeneity is like feedback. Endogeneity means your outcome variable is affecting your explanatory variable. Like you have the causality of the relationship backwards. So what we need from our instrument is exogeneity. We have to be really sure that war, in this case, the ultimate outcome, isn't driving rainfall, right? Or that economic growth rates in the country aren't driving rainfall. And this is why people like climatic data. People like weather data because whether or not there's a war on the ground, it's really not going to affect rainfall patterns above. Now you can imagine what if there was a war that, I don't know, maybe there'd be some extreme amount of pollution released as part of the war that would seed the clouds and increase precipitation or something. But basically, if you can look at the data, places that had more war in previous years have no different rainfall patterns in the next few years. These are governed by these global climatic phenomena. So it's almost like the ultimate exogenous variation, although the truly ultimate exogenous variation would be from a randomized experiment, from a computer random number generator. But this is a natural experiment that maybe gets us close. So this is a very, very important condition. The first condition was relevance for the first stage. The second condition is exogeneity, which is saying these rainfall patterns aren't being driven by other things that drive war. They're not being driven by war itself. They're just variation that's like a natural experiment. Let me pause. If there's any questions on that? Yeah.
What if the rainfall is related to the so rainfall
That is the third condition. So the third problem, or the third condition we need, is that rainfall is only working through economic growth to affect war. It's not working through the other axis. That's what's called exclusion restriction. In other words, we can exclude the possibility, say, that rainfall is affecting war through political institutions or ethnic conflict. All these other things we said might be driving war. This is often the most difficult condition to test or understand. Okay, three conditions. So quick question on exactly this, because I want you guys to think about the exclusion restriction. When you think about the exclusion restriction, remember the exclusion restriction was that, in this case, rainfall only affects war working through economic growth, working through economic conditions. Which of these other possibilities is one that you're really the most concerned about rainfall violating in terms of the exclusion restriction? Could it be the case that rainfall is affecting warfare by affecting road quality? So imagine you have a lot of rainfall, the roads flood, so armies can't fight each other. That could affect war. B, maybe there's economic outcomes other than per capita growth. Tara was hinting at that. Maybe it's rural income, maybe it's inequality, maybe it's something else, not per capita income. We're going to measure the per capita income. Maybe there's an effect of weather, not through economic conditions, but through individuals' mood or psychology. So there's lab evidence that at high temperatures, people become more aggressive. And it turns out in Sub-Saharan Africa, temperature and precipitation are very strongly negatively correlated. There are cooler, wet years, and there are drier, hot years. Maybe there's more violence in certain years because people are aggressive. Or maybe there's just too many that we've given up. What are people's thoughts? I want you guys to think. Actually, let's take another full minute on this and talk to your neighbors if you want about other potential violations. Because after we do the clicker, I'll ask people to come up with a few more beyond these three. So let's go to, say, 2 minutes, 15 seconds. Okay, so 22% of you said roads. Rainfall will affect roads. That's the most important one. That's A. 31% said economic outcomes other than GDP growth. 24% said mood or aggression. 12% said others or there's too many. So it's pretty spread out. Let me just take a couple of other channels that you might think of that would violate the exclusion restriction here. How else could rainfall be affecting war other than through these three in A, B, and C? Yeah. Yeah, so maybe migration, maybe it might be related to economic conditions. So it might be, the rains fail, so my income is low, and that sets off a chain of events. So you can maybe still interpret that as being driven by economic conditions, but maybe not. Maybe there's something about more like for flooding that pushes you off your land. Drought won't really push you off your land as much, but maybe flooding pushes you off your land and therefore puts you into conflict with other people because you're competing for resources with them. Elsewhere, so maybe migration might be under certain cases. Yeah. So resource scarcity. What would be some of the resources you'd be most concerned about? Yeah, so shortage of grazing land, shortage of water for cattle, etc., often puts pastoralist groups into conflict. That's very common in many parts, semi-arid parts of sub-Saharan Africa. And again, there's a broad sort of economic interpretation to it, like, oh, all my cattle are going to die if I don't, move somewhere else. But it's a particular channel that's different than GDP per capita per se. So it's sort of like another economic mechanism that's driven by resource scarcity, maybe. Yeah.
Communication channel, like if there's like nations that are like out free buildings for users to have central capital, maybe they're open to the way.
So maybe instead of just roads, broader sort of infrastructure destruction. Yeah. Of what? Oh, epidemic disease. Yeah, so maybe disease is a channel, and certainly weather could affect. So what you guys can see is there are a lot of potential channels here. And really for this instrumental variables approach to be valid, we have to have a sense that these other channels are basically minor. I mean, that's the thing. And when you read this paper, we struggled a lot in writing this paper. People hadn't used rainfall data this way before in economics or in political science, and we were trying to figure out how best to use it. And when we presented it, some people said, you know what, just show the relationship between the weather variables and war, show that kind of relationship. That's actually, someone asked, what is the reduced form? That's what the reduced form is. The reduced form is when you regress your outcome directly on your instruments. So I'll show you what those look like. The advantage of doing that is you might say, look, I have these instruments, so I have this instrument, and there are 2 or 3 plausible channels, but I can't really pin down which one's most important, but the sort of combination of those channels produces a certain effect on war. And if you look at a lot of the current research in this area on climate and conflict, including our own recent work on this by myself and co-authors, we typically focus on the reduced form, actually, because we're afraid there could be lots of different channels. When we wrote this paper, we were actually very focused on the issue of economic growth and conflict. And the whole point of getting rainfall was to get an instrument for economic growth. So even though we had reservations, we wanted to make the case that the leading explanation for why rainfall shocks led to conflict was working through economic conditions. And you'll see there's a bunch of the text in the paper trying to do that. We got some data on roads, and we said, look, at least the data that we have doesn't indicate that rainfall correlates with road quality. We tried to make the case about, you could try to make the case about aggression and say, well, maybe aggression leads to individualized violence, but large-scale insurrection that's organized, it seemed less plausible that someone being very aggressive on a given day is going to lead to a large-scale conflict, etc. So we try to rule out these channels more than anything verbally and make the case for the IV, but as you guys believe, based on your answers, and sort of our own thinking has evolved on this, it's hard to make that case in an airtight way. So we see this as an IV approach that has certain strengths, and the strength would be, if you believe it, it tells you how much growth, economic growth leads to conflict, but there's definitely room for alternative interpretations. Let me pause for a second and see if people have questions or comments. It turns out with a lot of instrumental variables that have been used in economics the last 15 or 20 years, once people think more and learn more about the instrumental variables, they're less and less comfortable with basically the exclusion restriction assumption. And so it's, you see lots of reduced forms for that reason. Yeah. With what? Can you speak up, sir? It just means you no longer attempt to say you understand the mechanism. You would say, look, I think there are these 4 potential mechanisms, and the combination of those 4 leads to this outcome. So, you could have exogeneity alone and say, look, weather is a natural experiment. It's not being driven by conditions on the ground. So it's as good as an experiment. And when the weather's bad, we see there's lots of war. And what people sometimes do is they do things that are almost like pseudo first stages. They say, look, I think there's 3 potential channels. I'm going to actually show you that rainfall correlates with these 3 things really strongly. Like it correlates with growth, maybe it correlates with aggression, whatever else. So these are all plausible channels, but I'm not going to tell you which one's most important. That's another way people are doing empirical work along these lines. When we wrote this paper, and we wrote it like 10 years ago, we were very much trying to make the case, and you'll see when you read the paper that it really is economic conditions. And if it is economic conditions, there's a bunch of implications. If we really think the economic channels are most important, then it would say one of the ways we should react to climate shock would be by insuring people against economic shocks. And beyond that, if it's really economic conditions that matter, then we should be insuring people against economic shocks that aren't even driven by climate variation. It's the economic shock per se that matters. So there's much broader policy implications if you believe the mechanism, if you believe it's economic growth, and that's what we're very much pushing for. That said, you can have doubts about that mechanism. Although I think most people that look at the data would think economic factors have to be important. They may not be the only thing, but they've got to be important. And there's actually some more recent work. I'm not going to get into it now because it's going to be too much of a tangent, but there's more recent micro work that I'll mention just very briefly, give you guys a sense of the style of work you need to do to get around these concerns. There's a recent paper by a grad student at MIT named Harari and Eliana LaFerrara, who's a professor at Italy. So they have a new working paper where they don't look at country data, they go down to the pixel level, and they classify, it's a tedious data test, they classify in Africa, pixel by pixel, what the relevant staple crop is, and they get data on, for that pixel, exactly what the growing season is for that crop locally. So they define the rainfall shock in terms of the relevant agricultural shock for the staple crop in that pixel. So very fine-grained data. And then they don't have country-level civil war data, they have pixel-level battles, clashes, riots, incredibly localized data.